Hello, boys. I, Dr. Pradeep Kumar Srivastava, welcoming to all of you in my surveying class. Today's topic is the computation and adjustment of level. Computation and adjustment of level. My dear boy, first we will think that what is the computation and how we adjust the level and what is the need of adjustment. Dear boy, when we are doing a large area survey, 200, 100 square kilometer, 200 square kilometer of a railway line or highway or a river bench, a river terrain, command area, so many things. It is all or vast and having big capillary of area. Now, why the question of computation? When you will doing the survey and after that you will compute and check and after that you will move. Suppose, my dear boy, you are working at a field book. So entire one page, this is the rule of survey. Entire one page when has been fulfilled, filled and complete, then you will find out the RL and difference of your will, they are filled, compute the all data and total backside minus total foresight. This difference is equal to the first RL minus last RL. This is computation. And now we will discuss about the adjustment of level. What is the need of adjustment of level, my dear boy? So sometime it has been mistake, has developed. Nobody knows. Nobody known how. Suppose your staff man had not fold full staff and you are taking the level. You are taking the level and you have done 8-9 kilometers. How you will find out? Who knows? Who knows where mistake has been done? Once upon a time, I have done around 46 kilometers of survey. That was the highway survey. And from one benchmark to transfer the second benchmark, when we have checked the other benchmark, they found the error. So what should do? First, we will study how much error have come. And thereby, their error was 30 centimeter error. So we have distributed that error entire all the reading. Around 600 reading. and it is very easily adjusted in every reading. In the case, in the case you are doing double leveling survey and staff man has not opened the staff full, so on that case both will be wrong and no way to the error adjustment. Otherwise, you do again from long 100 kilometer, 200 kilometer survey. And where you are found to benchmark, it is rule of survey. You check every point, every point. You are advised to check. Again, my dear boy, today's topic is again by repeating computation and adjustment of level. So we will discuss around this topic, around permanent benchmark, around permanent adjustment, and under all these topics. So let us start. First, what is the objective of this topic? Differential leveling observation are used to determine differences in elevation between stations. As with all observations, these measurements are the subject to random error that can be adjusted using the method of least square. The chapter explore the observation, equation, method for adjusting differential leveling observation by least square, and it presents several examples to illustrate the adjustment procedure. To apply the method of least square in leveling adjustment, a prototype observation equation is the first listed for any elevation difference. This chapter explores the observation. The chapter illustrates the application of weight to the least square adjustment of the level circuit by including the variable line length. It also presents examples files that are solved in the spreadsheet format. This file demonstrates how least square solution can be solved in a spreadsheet. It also demonstrates how to solve differential leveling problem using a higher programming language. Differential leveling observation are used to determine differences in elevation between stations. As with all observation, so these measurements are subject to random error that can be adjusted using the method of least square. In this chapter, the observation equation method for adjust different leveling observation by least square is developed and several examples are given to illustrate the adjustment procedure. Observation equation to apply the method of least square in leveling adjustment. A prototype observation equation is the first written for any elevation differences. Illustrate the functional relationship for an observed elevation difference between two stations I and J. The equation is expressed as by this formula. This formula. Okay, my dear. Now, this is the map of differential leveling observation. The prototype observation equation relate the union, relate the unknown elevation of any two station I and J with the differential leveling observation delta elevation Y and its residual. This equation is fundamental in performing least square adjustment. So we will discuss adjustment, surveying, measurement, etc. Dear boy, in my previous lecture, I think you have understand what is the leveling, but it is simple for your reminder. The general term applied to any of the various processes by which elevation of point on differences in elevation are determined. To measure the differences in height, maybe delta H, so between 2 points A and B, so vertical rod are set up, just wait. This is point A, B. Now vertical rod are set up at the each of these 2 points and a level somewhere between them. The height difference between A and B is the difference between the rod stop reading. Once the elevation of point is determined, that point can be used for determining the elevation of other point. This is the example for this. Correct? This is also example. This is also a diagram. Now, some definition. Leveling is surveying operation carried out to determine the elevation of point to find the difference in elevation of point. A spirit level or engineer's level. Actually, both are same. A surveying instrumental used to carry out leveling. Backshot, the backside also. A sighting with a level back to a point of known elevation and foresight. A sighting with a level to determine the elevation of a point. turning point, a point at which you have established on the elevation with foresight and which you will subsequently take backside like this. Thereby, this is your machine on the ground. This is your telescope. So first shooting, the first sight, this is backside. This is backside. Last level, this is foresight. Middle level, intermediate side. Now we will come at turning point. Thereby, this machine is here. We have shift. We have shift because we are doing a way on the survey of highway. So we relieve this person and set the machine here. A point at which you have established elevation with foresight on which you will be subsequently take a BS. Intermediate, just I have explained. Now some definition of peg test. Surveying operation carried out to determine if the leveling bubble or telescope line of sight are parallel. Now elevation of instrument. So elevation of the telescope cross here. Now balancing start. Attempt when doing and leveling survey to keep the length of FS and BS at any given instrument setup as close as possible. On a closure error different in elevation determined from the leveling survey and the known elevation of the benchmark. The design highway, rail, road, canal, sewers, and water supplies system having great line that best conform the existing topography. Now, to lay out construction project according to planned elevation and to calculate volume of earth and other material. The design, highway, road, canal, sewer, thereby this is the simple land You are making here a road, highway, rail. So this is the portion of filling, this is the cutting, this is the filling. So entire all these information we get from survey leveling. To lay out construction project according the planned elevation, to calculate volume of work and other material, how much quantum of aggregate will be required for the bed of the highway, how much quantum of the aggregate gone to the bed of rail line, how much earth square for the fill of the area, entire all these things to investigate drainage characteristic of an area. This is the equipment rod. It means you can see that it is staff. Now equipment rod or staff Philadelphia rod, Philadelphia rod, rear and double faced leveling rod. This is a rod or staff, both name are same. The equipment, rod level and tripod. This is rod level and that is tripod. This is the, my dear boy, level. When you will stand like this zero will be in the limit. When it will be left out, zero will become at corner. It means you are not standing through. Okay. Carrying and setting up a level. Always carry it in the container. Screw the head snugly on the tripod for bull eye bubble. Alternately turn on screw and then the other two, and on side heel set up place on leg by the pupil and the side and other two on the downhill side. Use hand level to check for proper height of the setup before precisely leveling the instrument wire. So carrying and setting up of a level. This is machine, this is staff. Now pond bubble. When pond bubble is centered, the instrument standing axis approximately vertical. See this. When pond bubble is centered, the instrument standing axis approximately vertical. The compens the compensator in the instrument take over and adjust the optical line of the collimation so that it is horizontal. When the instrument is rotated, now after now in the case of automatic level, after the pond bubble is manually centered and the automatic and compensator level, the line of sight and keep it level. This is the diagram of part and this is the part of ruler. This is the type of level 1.930, 1.920, 1.910, 1.90, 1.932. This is the type of level. This is the type of level. So level rod not vertical. Level rod not fully extended or incorrect length. Level instrument not level. Instrument out of adjustment and environment wind at heat. This is common error. Level rod not vertical. If a person is standing with rod, it may be like this, but he is like this. It is come error. Leveling rod not fully extended. It is open up to this area and open up to this. It is incorrect. Error come level instrument not level. Automatic level. Error instrumental out of adjustment. It is error environment wind and heat. If air is wind velocity is high or heat is high, so capacity of instrument is not tell it will be good. Suggested for the good leveling. Anchor tripod lift firmly. Check the bubble level before and after each reading. After each reading, check the bubble before. Take as little time as possible between backside and foresight. Try to keep the distance to the BS and FF equally. Equally means if you are taking the label, one rod is here, one rod is here. So try to fit your machine at the around same distance. Try to keep distance BS and FS equal and provide the rod person with a level to stand. Now, parallax is the apparent movement of the image produced by movement of the observer eye at the eyepiece. It is very common in the high heat. It is eliminated by focusing the telescope on infinity and then adjusting the eyepiece until the crosshair appear in sharp focus, so the testing will remain constant for a particular observer's eye. This is open leveling net or this is closed leveling net. Suppose you want to survey of a farmer's field, means you will be keep closed. If you are doing survey of a road or railway line, it will be open. Correct? Now close link the close connecting level nets. So leveling between 2 points is performed in two steps. The forwarded and backward. The height of difference is theoretically equal. It is perfect. Now height of the plane of the collimation method consists in finding the elevation of the plane of the collimation for every setup, the instrument and obtaining the reduced level of point with reference to the respective plane of collimation. The HPC method is generally used in profile leveling and in setting out level for constructional work. Now, HPC method, height of the plane of collimation method. So same start position as last reading, therefore the same row and new start position, therefore new row. So HPC is equal to reduced level plus backside. And reduced level is equal to HPC minus foresight. Or RL is equal to HPC minus intermediate side. This is the chart of calculation. Backside, foresight, and intermediate side. My dear boy, you see this? We had taken first backside, no intermediate side. So it's a total height of instrument. Next, this is the bench bar level. Now at second point, the rigid come, backside, foresight, it is inter, and this is the level come second. Now HPC method is second. Now backside, foresight, and intermediate side, HPC, RL, and demand. This is the HPC method. I mean, in both methods, you can adopt by the survey of the horizontal or in case of vertical. Front, it is a picture of the vertical. Now, differential levels and brand lake unique campus. This is calculation check. How you will check? So sigma foresight minus sigma backside. Sigma means total. Is equal to first RL minus last RL. And full checkup. Sigma intermediate side plus sigma foresight plus sigma RLS except first. So sigma each XPC X number of the application. Check miscellaneous. Available miscellaneous plus minus under root n under bracket mm. Rule of thumb. This is a thumb rule. When the calculation check and if the miscellaneous miscolors is allowable, distribute the miscolors. Suppose, my dear boy, you have 5 centimeter misclosures. So, number of points. How much number of points you have done? You have done 100 number of points. So, divided into every all. A method is separate, that is the rise and fall method. It consists in determining the difference of level between conjunctive point by the comparing each point after the first with the immediately preceding it. The difference between their stop and reading indicate a rise or fall according as the stop reading at the point is smaller or greater than the preceding point. The RL of each point is then found by adding rise or subtracting fall to the fall from the RL. The RF method, rise and fall, provided complete check on IS, and it is commonly used to differential leveling. And this is the IS method calculation. The rise and fall method. This is rise and fall method calculation. Rise will be add, fall will be minus in every RL. Now, rise and fall method, you have seen rise and fall method check. Fall is equal to how much level less, so foresight minus BS, fall is equal to intermediate side minus backside. So rise is equal to Bs minus Fs. So RL of previous RL plus rise. So RL is equal to previous RL minus fall. So this is collimation error. Two-peg system. This collimation error, my dear boy, the true height difference between the two statics. Suppose this is the higher belt and same point, same situation, same place you have measured, it is the lower place. So it means it is the error. Now surveyor's hand signal. If surveyor, this is the signal, is doing like this, this surveyor is doing like this, it means okay. And if it is like this, it means come at right. If it is the direction, it means stand for time like this. It means okay, stop. And the same the hand direction is for surveyor direction. Now surveyor's hand signal. All right, move right or left, give me a back side, give me a line of the side, the top, hop and plumb the rod, establish a turning point, and this is the turning point, and wave the rod. This is the signal arrangement. This is the signal, survey signal, face the rod, reverse the rod, boost the rod, move forward, move back, up or down, and pick up the instrument. Now benchmark is a point of known elevation. There are four kind of benchmark. So GTS you have read in my previous class, Great Technometrical Survey, that is the benchmark, permanent benchmark, arbitrary benchmark, and temporary benchmark. What is the GTS benchmark? Dear boy, they are benchmark established with very high degree of the precision at the regular interval by the Survey of India Department all over the country. Their position and RLS value over mean sea level, which was the earlier located at Karachi and now it is taken at Bombay, High Mumbai, and is given the category formed by the department. This is the GTS benchmark. See, this is design and this type of GTS benchmark will be done. Now, permanent benchmark are fixed in between GTS benchmark by government agency such as railway, PWD, and this benchmark are written on permanent object such as milestone, culvert, bridges, or their value are clearly written and the position of recorded for the future reference. And this is also permanent benchmark. You can see in this picture I have brought for your information. Suppose where you have seen, this is Jaisalmer, this is Dudhaicha, and the railway platform where this type of board is attached on the down of this type of permanent benchmark, you will be found what benchmark here they have given. Now, this is the permanent benchmark plate. Now, arbitrary benchmark. These are a reference point whose RLS and reduced level are arbitrarily assumed that they use in small work. Such benchmark may be assumed as 100 or 50 meter. Then temporary benchmark, they are reference point. Establishment during the leveling operation when there is a break in work or at the end of today's work and the value of reduced level are marked on the some permanent object such as the stones, tree, etc. This is arbitrary benchmark. This is temporary benchmark. See this. Now we will discuss temporary adjustment of level. These adjustments are performed at every setup of instrument, setting up a level, leveling of telescope, and focusing of eyepiece and focusing of objective glass. Setting up the level, so this include fixing the instrument on tripod, leveling the instrument approximately by tripod, and setting up the level machine. Now leveling. Leveling is done with the help of foot screw, and the purpose of leveling is to make vertical axis truly vertical, and it is done with the help of foot screws. Place the telescope parallel to pair of the foot screw, then hold the foot screw between thumb and first finger and turn the telescope throughout 90 degrees, and so it is the light parallel or third foot screw. Turn the screw until the bubble comes in the center. Oh, dear boys, I want to show you. This is the temporary adjustment picture. This is And this is the focusing eyepiece adjustment. It is the simple, you can move and you can adjust this. This is the temporary adjustment of automatic auto level. And now this topic has ended. So on this topic, I have prepared some MCQ and I want to ask you. So you are requested to please think that and give me reply. MCQ. Which of the following is caused by the careless handling? This is four answer which you are seeing at your screen and give me correct answer. So dear boy, is it correct answer is B. Now next question. A system will be error free if we remove all systematic error. What is the correct answer? That is answer B. In negative deflection, so that the magnetic meridian to the eastern side of the true meridian or western side of the meridian. So what is the correct answer, my dear boy? Correct answer is B, western side of the true meridian. Next question. A series of closely spaced contour. So line represent at a what represented? A step slope, a gentle slope, a uniform slope, or a plane surface? Answer is correct answer is a steep slope. And next question is a telescope is said to be inverted if it's so. In which are correct answer? Answer 4 all are on your screen. Correct answer A, vertical circle. Is it to right and bubble of the telescope is down. And angles of 45 with a chain on the may be set out with. Tell me correct answer. Correct answer is C, French cross staff. And next question. A level line is a horizontal line and parallel to the mean spherical surface of Earth. So which is the correct answer? Answer is B, line parallel to the mean spherical surface of Earth. And next, a gate tap heated with the this four answer is on your screen. Correct answer is D. This is a prismatic compass. And next, along the 0, 0 slope, the correction to be applied to each 30-meter chain length is correct answer is A. Then thank you for taking interest in my class. You are all are welcome in my next class that will be held tomorrow.